Hello grade 10s and welcome back to another video with me, Miss Martins. Please subscribe if you haven't yet. In today's video, I'm doing more functions past paper questions, exam past paper practice questions. I'm doing it from this exam. If you want to download the exam, get hold of it, do it with me, mark it with me. In this video, I'll be going over one question. In the very next video in this playlist, I go over the second functions question, so you don't want to miss that. Check out the links in the description box below for more functions videos, more past paper practice videos. Let's jump right in. In our first question, we've got sketch below are the graphs of f of x and g of x. Now, first thing that I want you to do immediately is to decide which graph fits with which equation. So we've got f of x is equal to ax squared plus q. As soon as you see x squared, you know you're dealing with a parabola, the quadratic function. So that is this function over here. It's a sad parabola, which means that a is going to be negative. Just keep that in mind. And this value over here is going to be your q value. That is your y-intercept. Then we've got g of x, and g of x has a exponent of x over here. So x is in the exponent, which means we're dealing with an exponential graph. And here's g over here. It's the exponential function. It approaches this asymptote over here. And you should know that the asymptote, the horizontal asymptote, is represented by this value over here. So we already know the equation of that horizontal asymptote, which again we'll get to. Another thing just to keep in mind, if this value over here, which is actually your b value, if I write it like this, a dot b to the power of x plus q, q is your asymptote, so q is -4, your horizontal asymptote. B, if b is less than 1, which it is here, it's a half, then we've got a decreasing exponential graph. Right, let's jump right in to all of these questions, and remember not to go anywhere, because after we do these questions, we're going to tackle this functions question. Our first question is write down the coordinates of D. Now D is over here. As you can see, and they do mention this in the little paragraph before the sum, D is the y-intercept of g of x. So D is the y-intercept of the exponential graph. And in order to find the y-intercept, we make x equal 0. So in the place of x over here, I will be putting 0. So this is how we do it. We go a half to the power of 0 minus 4. You should know that anything to the power of 0 is 1. So we've got 1 minus 4, and that is -3. Now, please be careful. They're asking for the coordinates of D, which means you need to give me a final answer in coordinate form. Remember, coordinates have an x and a y. So D, what is the x value? We made x 0. What is the y value? We just calculated it over here. It's -3. So that's your answer. Our next question wants the range of y. Now, if you watch my domain and range video, you will know that the range is all the y values. So remember, range with a g in it is all the y values. That's how I remember it. And domain is all the x values. They want the range of g. So you need to look at g. You need to consider where the graph exists or where the function exists for all the y values. So here's my y-axis. So the y values start over here. Okay, but it does not include, remember, what is this y value over here? We discussed it earlier. This dotted line is the horizontal asymptote for g of x. It's this value over here. So this horizontal asymptote is y is equal to -4. So my y values for g does not include that, because remember what an asymptote is. It means the graph will approach the asymptote, but it'll never touch it. It'll never cross it. So it's not including -4, but the y values are all of those above -4, so greater than -4. So you can write y is greater than -4. Please do not write greater than or equal to, because as I said, your graph, your function does not cut the dotted line. So it's not greater than or equal to, it's just greater than. This is another way to write the range. So y is an element of from -4, not including -4, so we use round brackets, to infinity. We never include infinity, so use round brackets. 5.2.1 says calculate the coordinates of A. Now, if you read the story, they tell me that A and B are the x-intercepts of f, which is the parabola. You can see it's where the parabola cuts the x-intercept. They also say the graphs intersect, which means the two graphs cut at A. We can also see, in addition to this, that A is actually the x-intercept of G. X is the is the x-intercept of my exponential graph. So if you look at the two equations that I have, the two formulae that I have, I cannot find A, the x-intercept of the parabola using this formula. How do we find the x-intercept? We make y equal to 0. But if I make y equal to 0, I can't solve for the x-intercepts yet because I don't know what A is, I don't know what Q is, I can't use this equation. But I know the exponential graph's equation looks like this. And I know that A is also the x-intercept of the exponential function. So again, to find the x-intercept, you make y 0. So in the place of g of x is the y values. In the place of g of x, we put 0, just like that, and then we solve for x. So what I did first is I took the -4 over, it became +4. Now what we want to do is, because we're basically solving an exponential equation, remember our steps for solving exponential equations are get the bases the same, then we can drop the bases. So how do I do this? Well, what I will do is I will rewrite 4 as 2 to the power of 2. Now, 2 to the power of 2, base 2, is not the same as base a half. But what I do know is that this over here is 2 to the power of 1 at the bottom over here. I hope you can see where I'm pointing. 2 to the power of 1. I'll draw it a bit bigger over here. Basically, I have a half like this. It's 2 to the power of 1. If I want to bring this 2 upstairs, that 2 is going to become to the power of -1. But remember, this whole thing had an exponent of x, the x will still be there. So basically what I'm doing is I'm taking this 2 upstairs. So it becomes 2 to the power of -1 to the power of x. Then you do power inside, what I call power inside, multiplied by power outside. You multiply those two together. So we get 2 to the power of -x. Then 2 to the power of 2. Now this is how I teach my grade 9s and 10s. Now you see that the bases are the same. This is a base and this is the base. The bases are the same. We can drop the base, get rid of the base. 2 is equal to -x. Therefore, x is equal to -2. Ooh, I'm writing that funny. X is equal to -2. That means that my coordinate A is equal to -2 and 0. How do you know? Because the x is -2. We just solved for the x. And we, in the place of y, we put 0. Like that in the beginning. So where you get your marks for this question is actually just for making it equal to 0. So for substituting 0 in the place of y, and then for your final answer. How you do the algebra is up to you. My next question wants me to get the values of A and Q. Now remember, A and Q appear in the following formula for the parabola, where A is over here and it dictates or tells me the shape of the graph, and Q is basically the y-intercept of the graph. It would be this value over here, which we don't know. This is an interesting question. This is a more difficult question. So what I've done so far is I've just filled in on the graph over here what we already know. We worked out that A is -2 and 0. That makes B +2 and 0. In grade 10, we work with the fact that the axis of symmetry for the parabola is this line over here, which is the line x is equal to 0. So if that that intercept, x-intercept is -2, this x-intercept is 2. Okay, symmetrical like that. So we know that point, we know that point. We also know the value of the horizontal asymptote down there, but that doesn't really help us here. What we also know that's given in the beginning in the explanation, and it's given on the graph, is a coordinate E, which lies on my parabola. Now, what we can do to find A and Q is to substitute points that lie on the parabola within the formula for the parabola. So this is what I mean. We're going to take the formula for the parabola, which is like this, and I'm going to sub in the following points, 1 and 3. Remember, this is a coordinate, so in the place of x, I'm going to put 1. In the place of y, I'm going to put 3. So I'm going to substitute it into this. Okay, so in the place of y, I put 3. In the place of x, I put 1. Okay, so that's what I got so far. Now, that seems like it's not very helpful at the moment because I still don't know what A is. I still don't know what Q is. We can simplify it even. 1 squared is 1. A times 1 is just A. So we got A plus Q equals 3. Doesn't seem helpful. But what I can now do is I can repeat the steps that I did over here, but I can use a different point and sub it into the same formula. So we're going to sub into the same quadratic formula, the same formula for the parabola, but now initially for this one, I used this point. We're going to do the same thing, but we're going to use a different point on the parabola. So I'm going to use A, which we found earlier, this coordinate over here. I'm going to substitute in here. Remember, this is X, this is Y. So in the place of Y, I put 0. In the place of X, I put -2 squared plus Q. We can simplify this. So -2 squared is 4. So A times 4 is 4A plus Q equals 0. I hope you are seeing what I am seeing, because what I have at the moment now are two equations over here. 3 equals A plus Q, and then we can actually rearrange this one further, but I've got 0 equals 4A plus Q. I have two equations. This one can be called number 1. I hope you see where I'm going with this. This one can be called number 2. We have two unknowns, A and Q. A and Q. So please, grade 10s, I hope you're thinking what I'm thinking, and what I'm thinking is simultaneous. So here are my two equations, and this one looks a bit strange. It doesn't really matter. What I'm going to do now is I'm going to do the simultaneous method called substitution. So that's when you have two equations, I need to make one of the variables the subject of the formula. So what I can do, for example, is I can say, okay, I'm going to take, it doesn't actually matter which one you take, but let's say I take this one over here, and I say, okay, I want to isolate Q. I want to get Q by itself. So I'm going to leave Q on this side of the equation, and I'm going to take 4A over. It was plus 4A. It's going to become 0 minus 4A, which is just minus 4A. So Q equals minus 4A. Now, how substitution works is Q is equal to all of this. Q is equal to that. I also have a Q in this formula over here. So what I'm going to do is, in the place of this Q, I'm going to substitute what Q is equal to. I hope that makes sense. It's called substitution. Basically, if this is your equation number 2 and this is your equation number 1, I'm substituting number 2 into number 1. This is not a sentence that you need to write. We don't care if you write it or not, but basically I'm taking whatever Q is equal to. So I'm taking this stuff, -4A, which is equal to Q. And in the place of Q, I'm going to put -4A. So this is how it would look, just like that. A plus Q, but instead of Q, -4A. You should know that a plus and a minus is a minus. So we've got 3 equals A minus 4A. So that is -3A. So therefore, A, it's times -3. So it's going to be 3 divided by -3. So A is -1. There we go. We've got A. Now, once you have A, finding Q is easy. You take your value for A. So you take your answer that you got for A and you put it in one of the equations. It doesn't matter which one. I'm going to put it in this one to find Q. So I have taken my value for A, -1. I calculated it over here. A, -1, substituted into equation number 2. So in the place of A, I'm putting -1. -4 times -1 is +4. So Q is +4. And there we go. We found A, we found Q. And just so you know what this means, that means that A has a value of -1, A is -1. It means that it's a sad parabola, which it is. It means that Q, the y-intercept, is over here, and it would be +4, which makes sense. That makes sense that it would be +4. And this would therefore be the equation of f of x. 5.3.1 wants the length of CD. Now, CD is a horizontal distance from here to here. It's that distance over here. If I know the coordinates of D and the coordinates of C, I can work out that that vertical distance. I keep saying horizontal, that vertical distance. We just established that because we found that Q is 4, it means that this value over here, Q, is the y-intercept of the graph. It's where the parabola cuts the y-axis. So this value over here is 4. That coordinate is 0 and 4. C is 0 and 4. Earlier on, we found that D was 0 and -3. Remember, 0 and -3, which means that on the y-axis, this value is -3. What this means is that the units from here to here, that's 4 units. 4 units. How do you know? Because the y value is 4. So to get from here to here, we climb 4 in terms of y values. And to get from, let's use a different color, from here to here, we go down by 3 units along the y-axis. So that would be 3 units. Therefore, the length of CD, 4 plus 3, equals 7 units. We would prefer you to show the 4 plus 3 so that we know that you are adding 4 because it's the y-intercept of the parabola and 3 because it's the y-intercept of the exponential. Another way to do it would be to use the y value of C minus the y value of D. You're basically getting the change in the y values. 5.3.2 would like the equation of a straight line through A and D. Now, there isn't a straight line there at the moment, but they mean if one existed, kind of like this. I just drew it in here in blue for you. They want the equation of the straight line. You should know that a straight line function exists in the form of y is equal to mx plus c. Now, there's a lot of different ways to get this equation. First things first, I'm going to get the easiest part out of the way. The c value is the y-intercept of the linear function or the straight line. And if you look at the blue line, the y-intercept is here. And we know what d is. We just discussed that d is 0 and negative 3. D over here, this is cutting, the straight line is cutting the y-axis at negative 3. So therefore your c value is negative 3. So we've got mx negative 3 and then y. Now, different ways to find m. You can either use the gradient formula, which if you don't know what that is, it goes change in y over change in x, or y2 minus y1 over x2 minus x1. If you're going to use this formula, you need 2 coordinates, which we do have. We know A, which is this, we found it earlier, and we know D, which is this, we found it earlier. You do y2 minus y1, x2 minus x1, you get the value for m. Or what you can also do is you can substitute a point in and solve for m. I'm going to do that. So what I'm going to do is we see that A, this point over here, this one over here, A also lies on the straight line. We know that A, this consists of an x and a y, it's a coordinate. In the place of y, I'm going to put 0 because it's over here, it's 0. And in the place of x, I'm going to put negative 2. So m, and then I'm going to go negative 2, and then bring the negative 3 down. Now, what do I need to do to get m by itself? This is minus 3 over here. We're going to do the opposite of minus 3 or subtract 3. We're going to add 3. So take it over, it becomes plus 3. 0 plus 3 is 3. And then we've got m multiplied by negative 2, which is negative 2m. Still, m is not by itself. To get m by itself, this is times negative 2. We need to then divide by negative 2. So that's my gradients. And I just wanted to show you that if you use the gradient formula and you use these 2 coordinates, this is x1, y1, x2, y2, you get the exact same answer. What this means is that we need to fill in the m value and the c value. So therefore, our final answer is y is equal to the m value, negative 3 over 2x. Our c value we worked out earlier to be negative 3. And that's your equation. Now, 5.4 is where my students often struggle. I know this can be confusing. So it says, for which values of x is f of x bigger than 0, greater than 0? Now, this is saying a lot of things. First of all, your answer must be in terms of x values. I want you to mention x values in your answer, not y values. So it says for which values of x. F of x, what does that mean? F of x is the y values for the parabola. Okay, so we don't care about the exponential in this question. And this means bigger than or greater than 0. In other words, all the positive values. Essentially what this question is asking is where is the parabola positive in terms of the y values? Where is the parabola positive in terms of the y values? So you should know that looking at this Cartesian plane, y values are positive here, which means that all of this, let me use a different color, all of these parts of the parabola from here to here, they have positive y values. If I had to take this part of the parabola, let's say I'm just going to choose a random point. So let's move me out the way. If I had to choose this random point over here, the y value is negative. Same thing over here. The y value is negative. But for here, from here all the way to here, not including the intercepts, from A all the way to B, but not including A and not including B, those y values, so go like this, that's a positive y value. Go like this, that's a positive y value. So it's the yellow highlighted piece. So easy enough to identify, but we need to write it properly. They say for which values of x is the y values bigger than 0, not bigger than or equal to, just bigger than. So it starts here. What is the x value over here? -2, but it's not including -2. So you say, okay, x must be bigger than -2. Then you carry on and on and on for all of these values, all of these values, all of these values, but not here. It stops here. Here, x is 2. X must be smaller than 2. Do you see how I'm not including? I'm not putting equal signs here because at these points here, so at this position over here, the y value is 0, but we're not including 0. We just said bigger than 0. So it cannot be including. How you read this inequality is as follows. You say x is bigger than -2, but x is smaller than 2. I hope that makes sense. X is in the middle because it's a range of values. So it's between this value and this value. Another nice way to write it, which some of my students prefer, is x is an element of -2 to 2. We use round brackets because round brackets means not including. Not including, you see, round brackets, not including because it's not equal to. And we start with the smallest value on the left, bigger value on the right. Another question, for which values of x is f decreasing? So how we do this is we read graphs from left to right. Okay, so we read from left to right. If you take a look at the parabola, because f is the parabola, if you read it from left to right, can you see that from here, from left to here, so from here, the graph is increasing. You see how it's going up, 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 up. Then it's stationary at the turning point. It stops for a second technically. And then from here, so from this point over here, f of x is decreasing. So basically, for which x values is f of x decreasing? First of all, f of x is decreasing for these values, but not including the turning point. So it's from here onwards. And remember, the question wants the values of x. So we're starting at this x value, this one over here, and we're going onwards that way. But it's not including this x value. Why? Because over here the graph isn't decreasing, it's stationary, it's the turning point. So basically, what is this x value over here? That x value is 0. So basically, where x is bigger than 0, that's where f is decreasing. Or we can use this notation over here. X is an element of from 0, but not including 0. So we use our round brackets to infinity. Never use square brackets, only use round brackets with infinity. I hope that this video has been helpful. In the very next video in this playlist, I go over this question behind me. It's from the same past paper. So please make sure to check out that video right now. Subscribe for more videos like this. Bye, everybody.